In this AP Calculus example, we're being given a function here. F of x is equal to kx over 4x squared plus 1. And they're telling us that k is some constant, some number that doesn't change. And they want to know for what values of k would make f strictly increasing on this given interval right here. So not over the entire function, but just over that one interval. So when we talk about strictly increasing, the word increasing, decreasing should always kind of tell us that we want to be talking about a first derivative. And for something to be increasing, we know that our first derivative needs to be positive. Our first derivative needs to be greater than 0. And so what we're probably going to want to start off with here is we're going to want to try taking our derivative and seeing where that gets us, because we need to figure out how to make our derivative always positive, not through the whole equation, remember, as we do this, but only on this little one interval right here. So we'll grab our f of x that they gave us. We have f of x is equal to kx over 4x squared plus 1. And we're going to want to find the derivative of that. Well, we obviously see that we've got two chunks being divided, and anytime you've got two chunks being divided, you're going to need to follow your quotient rule. So the quotient rule recipe, you got to have a rule that it just memorize like the back of your hand for all these things that you can just spit out of your head. My quotient rule goes low d high minus high d low, and all of that is over the low squared. So I label the top piece the high piece, the bottom piece the low piece, and when I say d high, that means the derivative of the high piece, and when I say d low, that means the derivative of the low piece. So I'm going to break it into bite-sized little math problems now. So the high is kx, the low is 4x squared plus 1. So now we'll go find the d high. So as we do this, remember that k is a number right now. So when I'm coming to take the derivative of kx, it's really like if I walked up to you and said, how do I take the derivative of 5x? Well, the derivative of 5x would just be 5. So the k is behaving just like that 5. So the derivative of this would just be k. Then to go find my d low, following my power rule, bring in the power down, subtract 1 from the power. I get 8x to the first, and then the derivative of 1, the derivative of a constant, is always 0. So now that we have, I just call these my ingredients, and I'm ready to follow my quotient rule recipe to get my derivative. So the derivative here, f prime of x, would equal low 4x squared plus 1, d high, which would just be k, minus the high, which is kx, multiply that by the d low, which is 8x, and all of that is over the low squared. So 4x squared plus 1 squared. Now, if we're going to solve this out, we know that the places where it could potentially change from positive to negative are going to be where this equals 0. So it's very much like doing a first derivative test right now. I want to know when would this equation here equal 0. And so we set that equal to 0. Maybe clean it up a little bit as I go. So kx times 8x would get me 8kx squared. And on the bottom, I've got 4x squared plus 1 squared. The first thing I'm going to do when I work an algebra problem like this is I'm going to multiply by this chunk that's on the bottom here. I'm going to take advantage of that 0 on the other side to get myself a little less math to work with. So I'm going to multiply both sides by 4x squared plus 1 squared. 4x squared plus 1 squared. And what that does is on the left side over here, 0 times anything, I love it because it's 0. And then I bring it back together and I've got 4x squared plus 1k and then minus 8k x squared. So we'll keep working this algebra. We'll kind of bring it up over to this side here so we can keep working it because we obviously got a little bit more ahead of us here. And again, remember what we're trying to do is find when this thing equals 0 so that we can see what's happening in those other regions around it. It really is just like a first derivative test. So my next move is I would go ahead and try to clean this up, distribute this k into everybody here. So I get 0 equals 4kx squared, and then k times 1 would get me plus k minus 8kx squared. And then I've got like terms going on here, so I can rewrite that. Negative 8kx squared plus 4kx squared gets me negative 4kx squared plus k. To see what this k, this constant, is doing to this whole thing, at this point, notice that there is a k in both pieces here. And so I'm going to pull that k out to the front. So I get 0 equals k, and then I've got negative 4x squared, pulling k out of that first chunk. And then I have a plus 1 from pulling k out of the second chunk. And again, I need to know what's happening with k. If you look up here at your answers, right, it's basically saying k is negative, k is equal to 0, k is positive, or k is greater than 1, so somehow it's, just being 1 or bigger is going to make a difference. And then e is no such value of k. So what I'm really looking at right now is saying to myself, what is going to happen if this k is a plus, or what is going to happen to this equation if this k is a minus right now? I know what happens if it's 0. You can kind of throw that out, right? Because 0 times anything is 0. And remember, we're trying to make this thing strictly increasing, so we want to know right now, when would this derivative be positive? And keep in mind that what we're doing algebra on right now, this is our derivative. So let's keep finding where those zeros are happening. So I'm going to take now and I'm going to set just this one piece, negative 4x squared plus 1 equal to 0. And we'll keep solving that out. So we'll add the 4x squared over. We get 4x squared equals 1. Go ahead and divide by 4. Divide by 4. We get x squared equals 1/4. And now we're going to square root both sides of this. Remember, when you do a square root, you get the plus or minus. So this is going to be x equals plus or minus the square root of 1/4. So we get two answers out of this, right? So x equals the negative square root of 1/4, and x equals the positive square root of 1/4. And remember, when you're working with division and square roots, you can break that up. That would be the square root of 1 over the square root of 4, which is negative 1/2. And then this again, we could break up the square root of 1 over the square root of 4, which is going to be 1/2. And if you look here, somehow magically those pieces end up equaling the same interval that we're looking at. So we know right now, if you think about this in terms of a first derivative test, a number line, we know that from negative 1/2, that's actually a critical value, and at positive 1/2, that's actually a critical value. And what we're being asked about right now is we're being asked about what's going on in between these two pieces. And specifically, what we need to have happen is we need to make sure that whatever goes on inside there, that it is always positive. So we know it'll never change, whatever sign we make it, because it only changes at critical values. So you come back up and say to yourself, okay, here's my derivative sitting in the middle. I've got k and then negative 4x squared plus 1. That's what's going on in the middle there. Well, let's do similar to a first derivative test. Let's choose a test value from inside this region. Let's let x equal 0 and plug it in right here and see what that would give us. So if I plug in 0, I would get negative 4 times 0 squared plus 1 is going to give me 1 out of there. So 1 is a positive number. And so what I know is if I'm going to make sure it stays positive, k also needs to be positive right now. So what this is showing me is that as long as k is a positive number, a positive times a positive is going to give me what I need, which is a positive in this situation. So that's telling us that k has to be greater than 0. If I wanted this to be strictly decreasing, I would have told them that I want k to be negative, because a negative times my positive here, that would have given me a negative across that entire interval, which would have been strictly decreasing. So when you do this, it's really very much like a first derivative test. Get it all the way down, and then just like a first derivative test, choose a test value to see what the sign of that math is there. And then based upon that math, you now know what your k value has to be, positive or negative. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.